Hello. I am going to talk about a precise scale-up method to predict particle delivered dose in a human respiratory system using rad deposition data. We know that rats are frequently used in preclinical trial of pulmonary drug particles or in inhalation toxicology tests. And we can see here the morphology of the human airway and rat airway are similar to each other. But going through the literature, we realized that projection of human rat study data into human study data based on the ratio of their body weight or the volume of their airway or the surface area of their airway will not give us an accurate extrapolation. And we also realized that in vivo and in vitro studies have some limitations. So we did in silico studies. The method that we used is numerical method, which is computational fluid-particle dynamics method. And using ANSYS fluent meshing software, we discretized human airway model into more than 7 million polyhedral elements. And we discretized also rat airway into more than 11 million polyhedral elements. And for both models, we use 5 near wall prism layers to resolve the boundary layers near the wall. And these are the meshes of rat airway and the human airway. And using ANSYS fluent, we modeled the air and the particle tracking. For both models, we initiated the airflow from the nostrils. For solving the flow, we used SSD turbulence model, and for tracking the particles, we solved equation of motion of particles. For involving morphological differences of rat airway and human airway, we injected the particles based on the value of their Stokes number. For rat, it was between 0.6 and 6 microns, and for human, it was between 1 to 13 microns particles. And we injected the particles under resting condition, breathing condition, and we realized that inhalable aerosols have different sizes for human and rat airway. And also we obtained that aerosol deposition in human and rat airway is not comparable based on their size, but we should compare them based on their Stokes number or Froude number. Using Froude number, we involve the gravity in our simulation because some of the large particles deposit because of their weight. And when we plotted the position fraction of particles versus the Stokes number or Froude number for both upper and lower airway of human and rat airway, we saw they both follow the same pattern. And using these data, we generated a correlation, and we realized that using that correlation, we can project rat study data to human study data. In summary, we realized that aerosols are larger than 6 microns and 13 microns can be considered non-inhalable for rat and human, respectively. Also, we realized aerosols with the same value of the Stokes number or Froude number have similar value of the position fraction in human and rat upper and lower airways. And also, we understood that using a correlation, rat study data can be extrapolated to human study. And in last, I would like to thank the Oklahoma Center for Adult Stem Cell Research and NIH Center of Biomedical Research Excellence. And I also would like to thank Korean Models, and we used ANSYS software as a part of the ANSYS CBBL academic partnership. And I also like to thank Dr. Corley and Dr. Kuprat for providing us the RAD model. Thank you very much.